Now let's look at point-slope form of a line. This is a very important format for our line. It's very easy to write equations in point-slope form because you can use any point. Right? So the equation of a line that passes through the point x1, y1, some point, and has a slope m can be written as y minus y1 equals m times x minus x1. So x and y in that equation are variables. We're going to use one point and the slope. Right? So the nice thing about this equation, this format for the equation of a line, is that it doesn't matter what point you use. You can use any point on the line because the relationship between any x value and the corresponding y value is going to remain the same. Let's take a look at writing the equation of a line if we're given a point and the slope. And then we'll graph the line. Right? So we want to find the equation of a line through 1, negative 3 with a slope of negative 1/2. Right? So remember the format, and these are all in your notes. We have y minus y1 equals m times x minus x1. The point that we're given is a point on the line, and of course m stands for slope. So the equation of the line in point-slope form would be y minus a negative 3 equals negative 1/2 times x minus 1. This is our equation in point-slope form. And if you're, oops, let's actually simplify that, sorry. Y plus 3 equals negative 1/2 times x minus 1. Simplify the double negatives there. And it's fine if you do it in your head, right? You know, minus a negative is going to be a plus. So this is the equation of the line in oops, it's caught there, point-slope form. This is a perfectly acceptable format for our line. Right? That's point-slope. If you're asked to write the equation in slope-intercept form, you simply simplify it. Right? So if we were asked to find the equation in slope-intercept form, right, then we would simply distribute the negative 1/2 and isolate y. So in slope-intercept form, this equation would be y plus 3 equals negative 1/2 times x is negative 1/2 x. Negative 1/2 times 1 is positive 1/2. And then to solve for y, we would subtract 3 from both sides. Now, we need our form of 3 here on the right-hand side to have a denominator of 2 to be able to combine it with the 1/2. So 3 is the same as 6/2. So this gives us y equals negative 1/2 x. 1/2 minus 6/2 is negative 5/2. And that is the slope-intercept form of the line. Right? They're just two different formats for our line. Right? Now, for graphing purposes, let's use point-slope for a couple reasons. First, that's what we're reviewing, point-slope form here, not slope-intercept form. And secondly, it's going to be easier to graph in point-slope form. I would much rather graph the point 1, negative 3 than graph the point negative 5/2, 0, and then use that to count more points. All right, so let's graph our line. So to graph your line in point-slope form, you're going to first, step 1, graph the point you're given. In this case, instead of graphing the y-intercept, let's graph the point 1, negative 3. Right, so there's our point 1, negative 3. Our second step, step 2, use the slope to count more points. Right, the slope here is negative 1/2. That means we have either a rise of negative 1 and a run of 2, Or you can think of it as a rise of 1 and a run of -2. In other words, we can count 1 down and 2 to the right, or 1 up and 2 to the left. In either way, it's still the same slope. I've got my microphone caught here. I thought I got the knot out. Instead, I made the knot worse. So don't mind me. I'm just going to try to get rid of this knot so I have more space. There it goes. Okay. All right, so let's count down 1 to the right 2, down 1 to the right, down 1 to the right, down 1 to the right. We could also count up 1 to the left. Now, you can get as many or as few points as you want, so long as you have at least 2. Since I seem to have trouble with my straight lines, I like more points, especially on the smartboard. So then we just connect our points, and that looks like I'm going through most of my points. And we should draw arrows on both ends because that's going to keep on going. So there's our equation in point slope. All right, a lot nicer than trying to graph -5/2 and counting down 1 to the right 2. Right? You can see that would have been a little harder. Let's write another equation. This time we're not given the slope. If you're not given the slope first, well then step 1 is going to be find the slope. Right, so remember our slope is the difference in the y coordinates over the difference in the x coordinates. Right, so that's going to be 2 minus a -4 over -1 minus 3. 2 minus a -4 is the same as 2 plus 4, so that's going to be 6. -1 minus 3 is going to be -4, and that's going to reduce to -3/2. So we're divisible by 2 there. All right, now we have the slope. We can use either point to write the equation of the line. So use either point to write the equation of the line. And so that means I can write it as y actually I'm going to write that format. Y minus y1 equals m times x minus x1. So I could write that as y, if I want to use this first point here. Right, so I'm going to use the number 1 there. So that would be y minus 2 equals -3/2 times x minus a -1. Simplify the double negative. Y minus 2 equals -3/2 times x plus 1. Or, if I want to use the other point, y minus a -4. I've got one too many parentheses there, equals -3/2 times x minus 3. And we should simplify the double negative to y plus 4 equals -3/2 times x minus 3. I think on this one, we're going to leave it just in point slope form. If it doesn't specify which format, you can leave it in point slope form. So this equation or this equation, even though they look different, represents the exact same line. Right? If we were to simplify it to slope-intercept form, we would have the exact same equation. Right? So this is just using point 1, and this is using point 2. But they represent the exact same line, and they are equivalent, even though they look a little different. And that's where we're going to stop, right? And then we'll look at slope-intercept form, and on that video we'll simplify more of the point slope forms to slope-intercept form. Thanks for watching, and bye for now.